Okay, guys, geometric mean again is going to find the geometric mean between two numbers. We're going to go ahead and solve problems involving the relationships between parts of the right triangle, and the altitude to its hypotenuse. So the geometric mean, okay, is going to be right here. You have a proportion, x is the same number. It's a cross product, right? And x would be like x squared is equal to the cross product here of a and b. Get the square root, and it gives you this. So the geometric mean is going to be this. X is equal to the square root of a and b. A and b are these numbers over here. You'll see what they are right now. Copy that down again, like give you like 30 more seconds. Okay, let's go and move up. Here, let's go and find the geometric mean between 8 and 10. So if you want to think about that, that's like these numbers right here. Okay? So the way you get the geometric mean between 8 and 10 is basically cross multiply, where you'd wind up with the square root of AB. And 8 and 10 is A and B. So we're going to have with that 8 times 10, which is 80, slash, you can go ahead and break this down. Now we want this kind of answer. So you got to remember how this was set up. For every two of the same, you can kind of say factors, and you want to go, sometimes you want to make them, or you can get them down to the prime factorization, cool. If not, if you can see them from the beginning, you can pull those out. You see right here, these two, I could pull that 2 out. You see the square root of 4 is a 2. So give me a 2 and a 2, which gives me that 4. Or you can say, well, all these together, 16, which is the square root of 16 is just 4. Bring that out. That 5 has nothing, no pairs, no anything to go with. So that 5 would just stay underneath. So this is actually the geometric mean of 8 and 10. Okay? I want more of these than this, but either way, that's the way it goes. Again, to get the geometric mean, just multiply them and get the square root of it. Multiply these two and get the square root of it. Let's go ahead and try 1A. Real quick, I'm looking at the messages, the chat. Anybody have any questions on this? Anybody have any questions on geometric mean? So they come out here and say, give me the geometric mean of two numbers. You basically multiply them and get the square root. Let's go and try 1A, guys. Copy that down real quick. Okay, so let's look at this one. Ready? So to get the geometric mean of 5 and 45, we're going to basically get x is equal to the square root of a and b. And we'll go, this is a and this is b, so we're going to go with x is equal to the square root of 5 times 45. Now we're basically going to multiply this out. You can really multiply this out, and 5 times 40 is 200. 5 times 25, 5 is 25, so it'd be what, 225? You can do that, but you're going to basically break it back down. I wouldn't do that. I would just start separating this one here. This is a 5, and then this one right here, I'd break it down into a 5 and a 9. Now, that is kind of, you know, that one right there is kind of like done-ish. For these two, you're going to put out a 5 of the square root, right? But remember, this 9 here is really a 3 times a 3. So I'm going to, for those two, I'll put out 1 here. All right? 1 there. So underneath the radical here, underneath, there's really nothing left. So I'm going to say x, okay, which is the geometric mean of 5 and 45 is what? 5 times 3, 15. Okay, let me redo this one. Kind of did it really, really fast. And I think Diego just joined us. Let me go back and help Diego out. Diego, so we're finding the geometric mean of two numbers, 5 and 45. So we're going to go x is equal to, we're going to multiply this one as a and b. We're finding the geometric mean between two numbers. So basically get like a and b, multiply them together, and get the square root of it. So I'm going to have here underneath, I'm basically having a 5 times a 45. Now, we basically want to get the square root. When you get the square root, if you can, if you don't mind, try to break it down to factors. Every factor that has like a pair, you pull out one of those factors. So I'm going to break this down. In my head, I can see this, how this is going already. This is going to be a 5. This one is a 5 too, times a 9. I guess I should just continue going down, right? So don't be so messy like last time. And I have 5 and a 5, which are these two 5s. This one breaks down to a 3 and a 3. So for every pair, for every 2, this 2, I can put out a 5. This 2, I can put out a 3. Slash, there was always a pair. Nothing was left under here, so we're going to go with that. 5 times 3, which is what, 15? The geometric mean is 15. Okay, I'm looking at the chat. Any questions, guys? Any questions? Any cues? How about that? You don't mind? If not, try 1B already. Try 1B already. Okay, so let's look at number 1B. We're going to go this one as an A and this one as a B. So we want the square root. Okay, we want x. The geometric mean, we're going to go with geometric mean here, is equal to the A times a B, and then get the square root. So I'm just going to go ahead and start throwing that in there. So what I see that these are both, they have a factor of a 3, all right? They're both divisible by 3. So I'm going to break this one down as, oh, I can see this. 4 and a 3, right? This one here is a 3 and a 5. Right? And then this one. I'm just breaking it down. What multiplies together? You see this 4. I know that one breaks down to a 2 and a 2. Then I have this 3 and this 3. And then I have a 5 here. Okay, so this one breaks down to that. This is that one. This is that one. I haven't forgotten anything. And the 5 just came straight down. So when I have the 12 times the 15, these are all the factors. Okay, and a square root, you want to kind of simplify it, guys. You don't want to just leave it like this big number. It'd be like huge. I don't even know what it'd be, but something not nice. Okay, so I want to come back here and I'm going to say for these two, I'll put out a 2. For these two, I'll put out a 3. 5 stays by itself, and there it is. On the answer right here, we're going to clean that up. We're going to go with x is equal to 6 times the square root of 5. There she goes. What do y'all think about that? Is it hard, easy, medium? Let me make sure I'm in the right class. It's super quiet today. My heart's breaking because no one has posted anything. All right, Sam, thank you so much. Here, don't forget the paste then. So I did jump to chapter 8 already, and I skipped most of chapter 7 because all y'all were saying that similar figures was too easy. I agree it was. Geometric means, okay, in right triangles. Now we're going to go to the right triangles idea. In a right triangle, an altitude, remember that altitude, it's like how high it is, basically with a right angle on the bottom, drawn from the vertex of the right angle to the hypotenuse forms 2 additional right triangles. These 3 right triangles share a special relationship. So let's look what this says. So when you have the right triangle and you draw an altitude from the vertex of the right angle to the hypotenuse, okay? So when you get this right triangle here, the right angle right here, and you draw the altitude, you see that? This is the right triangle, right angle here. when you draw the altitude, basically from that vertex where it has a right angle to the hypotenuse, the side across it, something happens. Okay, here it goes. If the altitude is drawn to the hypotenuse of a right triangle, okay, so the altitude from here to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. So what do you mean, the two triangles? Well, when you draw that, you got that? It forms this right triangle here, and then it forms this right triangle here. Okay, so now if you think about that, there's three triangles. Well, what do you mean three triangles? Well, you form this one right here, you form this one over here, and then the original right triangle. So it says, then the two triangles formed are similar. Similar, what that meant was, remember that meant that the angles are all the same. The corresponding angles are the same. And then the corresponding parts were proportional. So here it goes. If CD is the altitude to the hypotenuse, so if CD is the hypotenuse right here, okay, I'm sorry, the altitude drawn to the hypotenuse of the right triangle, then the small triangle, okay, then the big triangle, ACD, right, the big triangle, is similar to ACD or ACD. The other small blue triangle is similar to the big triangle, ABC. And then these two are similar to each other. So do me a favor, guys, write this down real quick. We will have this, and we have to identify this. And this is the part that sometimes gets people the issue. Sir, this is the one I couldn't get. And it just takes time to go in here and understand what's going on. So when this hypotenuse is drawn, when this altitude is drawn, you basically have three triangles. Make sure you know that. You're going to have the original one. Okay, it has like this. There's the original one. Then you're going to have this medium one. And then you're going to have a small one. And they're all, what are they? Similar to each other. So this next section that we're going to work on right here is basically identify the similarities. Which one goes with what? So in the big right triangle here, this is the right angle over here. Oh my gosh. So I guess we should draw these the same way. My bad. And let's just go like that. Name the the big, medium, large. And that's it. We're going to practice that today and right now. So again, when you have a right triangle, I'm going to just make one right triangle up like this. This is my right angle. When you draw this altitude, remember the altitude goes perpendicular to the base. When that happens, you form three similar triangles. Let's go to practice real quick. Write a similarity statement identifying these three similar right triangles in the figure. So here is the original right triangle. If you can't see it, I'll kind of outline it real quick and then I'll erase it. This is the original right triangle. The altitude goes from this corner all the way to the hypotenuse. And again, it's perpendicular because that's your altitude. How do you measure the altitude? You measure it perpendicular to the ground. So imagine it like this. The right angle here, imagine they went straight down. And they figured out the distance from here, this vertex, the right angle vertex, to the across hypotenuse, right? Once you have that idea, now you have a small triangle, a medium triangle, and then the big original triangle. And we want to go here and name the three, right? That's it. So let's come out here. Separate the triangle into two triangles along the altitude. So we want to come out here, that altitude was drawn here. You have a small triangle, and then you have this medium triangle. Then sketch the three triangles. We are inserting the smaller ones so that the corresponding angles and sides are in the same position to the original triangle. So that's what I would do too. Make sure this one, and this one kind of all look the same. So when you talk about J G here, you're talking about JH here, and you're talking about GH here. So you're going to have to keep track of all these things. You have to keep track. Now, I usually like this, put the right angle in the same spot. And this is how you can easily do this one, in my opinion. You're going to have a longer side and then a shorter side. You have a longer side, shorter side. Longer side, shorter side. And then you just connect them. You're going to obviously know the longer side, that vertex over here. You know, the shorter side, vertex here. And then you just kind of go in the same order. When you name the first one, it doesn't matter which order you name the first one. They went F, J, G. F, J, G. So if you name that one this way, then you better name this one in the same direction. Starting at the same one, finishing with the same one that is in its corresponding spot. Start with the same corresponding angle, vertex, I'm sorry. Then proceed in the direction of the right angle, you see that? FJG, GJH, and then do the same thing for the last one, or the original one, whatever you want to call this one. Start here with that one that has a shorter side, FGH. And they're all similar to each other. You okay with that one? Not too bad. Okay, let's move it on up. Good Lord. Okay, let's go and practice this one too, guys? Okay, so draw the original figure here. Now, please identify here as your right triangle. That's going to be your altitude there. So this will be your small triangle, this will be your medium triangle, and the whole thing will be your large triangle. So I'm going to do like the book did it. And a small one. Now we'll go with a medium one. Then we'll go with a big one. Now this, I remember last year, Jake and Lázaro and all those guys, they kind of had issues with this one, just because they wouldn't take the time to do it. Draw it out, makes your life a lot easier. Okay, so the small one, this is my right angle. So the right angle, the small one that has the right angle is P. You okay with that one? Y'all see where I'm going in there? The smaller side would go P to K. And then obviously the other one has to be over here to M. Now the medium triangle. Where's my medium right angle? Okay, right here. See, since this is a straight line, that's a right angle there. That has to be another right angle here. So that's my right angle, vertex P. Now we're looking at this part here. This triangle right here. Let me just kind of go over. I'm looking at this one for the middle one. What is the shorter side? The shorter side, I'll put it here. I guess I'll put the shorter side here, just so you can know. Shorter side would be P to M. And then the other one would be P to L. Not too bad. Now let's go to the big triangle. The main one. The right angle here is M. The shorter side, M to K, and then M to L. Okay, and there it is. Those are your right triangles that are kind of, formed when you draw the altitude from the right angle to the hypotenuse for a right triangle. Okay, guys. Now, when it comes to this part real quick, they want you to write a similarity statement. So what's my similarity statement? So I'm going to go with triangle. I'll do it the same way the book did it. KPM. KPM is similar to triangle MPL. Similar to triangle KML. 'Cause, 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 'cause This is not doing red. Okay, to be or not to be, guys. Finally is the question. Try to be, guys. While you all are trying to be, if you got 2A, perfect. Moving on. Did anybody have any questions on 2A? Have you all been outside today? It's kind of chilly. Super nice. It's going to be a beautiful day. Like barbecue weather. Again. Okay, how do you all feel? All right? So I'm going to approach it the same way. So there's 3 triangles that are formed. Okay, we have the original right triangle, the big one right here like this. We have the geometric mean, right? The idea. We're going to come down here. This is my altitude. So we're going to come out here. 3 triangles formed. So I'm going to go with the smaller one. I'll do it like the way the book did it. And then a medium one. And then the big original one. So I'm going to go with the right angle, and the small one would be over here where T is at. The shorter leg would be TR. TR, and then what? TS. This one would be T. We're looking at this triangle now. The smaller side would be TS. The longer side would be TQ. Oh, I forgot to mark the right angles here. Big triangle. I'm going out to the big one out. The right angle would be S over here. The shorter side would be SR. And then the longer side would be SQ. So we're going to come out here and name the triangles. The triangle similarity statement would be triangle, right? You can do any direction. What do y'all think? Same direction, or we try it another way? All right, we'll go same direction, not to throw people off. RTS is similar to STQ. To triangle RSQ. Not too bad. Not too bad, everybody. Not too bad at all. RTS, STQ, RSQ. Good job, Diego. Thank you so much for participating, brother. Okay, do any of you have any questions over this madness? Hey, Fabian's in the house. Yeah, big dog. Okay, so let's look at this real quick. From Theorem 8.1, so you know these triangles, right? You know that the absolute CD draws the hypotenuse of the right triangle, ABC, forms 3 similar triangles. So we have these small one, the medium one, the bigger one. By definition of similar polygons, you can write the following proportions comparing the side lengths of these triangles. So if you have those 3 triangles and they're similar, then you can write proportions. Do you agree? Because they have similarity / the side lengths are proportional. Pretty cool, right? So if you compare the shorter legs to the longer legs, look what happens here. If you compare the hypotenuse to the shorter leg, look what happens here. If you compare the hypotenuse to the longer leg, look what happens here. What I'm saying is look at the geometric mean idea happening here. Do you see the geometric mean? This is like your x, and this is AB. Pretty cool, right? So help me out. Are you all ready? So this is what happens. On the big triangle here, woo, we can find out our hypotenuse, our height, knowing x and y. Now for a right triangle, guys, this is way better, like if you think about the a squared plus b squared equals c squared. Sometimes they give you this one here, and you have to figure out this one to figure out this one. This saves you a lot of time if you remember it. If not, the Pythagorean theorem still works. Look what you can figure out here. Okay? You can figure out B. You can figure out this side length, knowing stuff about this one, and C. You can figure out A, knowing Y and C. This stuff here becomes a game changer, which is super sweet, knowing the geometric mean. I'm going to give the time, guys, 9:05. What we're going to do here is we're going to stop for today. Okay? We have the lesson. So what I'm going to ask you all to do, guys, is go and log into Alex. For Alex, we're going to work the rest of the period. Just put some time in topic. Remember, the time and everything is due on what day, guys? Do y'all know what day Alex is due? Alex is due on Thursday. Y'all should know that already. So I'm going to go to y'all's class here. Yes, sir, Matthew. That's due on Thursday. I'm going to get your reports. I need you to log in at Alex and put some time and practice in here. So for today, did y'all know today's February 1st? What? Almost spring break. So Monday, February 1st, I'm going to look at the time. But nobody has logged in and done any Alex. Oh, wait, somebody did something. Well, what does that mean? That's cool. Wait, Jasmine put in an hour? But no topics. Okay, so let's start working in it today. So here for February 1st, Monday, for the rest of the period, you got about 20-something minutes. Put some Alex in there, guys. Put some Alex. Do some time.